Now it's your turn to graph a parabola using the intercepts. If you've not tried this example on your own already, please pause the video, attempt this on your own, then return to the video to check your work. For the equation y equals x squared minus 2x minus 3, complete the following. In part A, algebraically find the vertex. To find the vertex, we use the formula x equals the opposite of b over 2a to find the x-coordinate of the vertex. Applying that formula in our situation, we would end up with x equals the opposite of negative 2 over 2 times 1. The opposite of negative 2 is 2, and 2 times 1 in the denominator is 2, giving us the fraction 2 over 2. And 2 over 2 equals 1. To now find the y-coordinate of the vertex, we will substitute 1 in for the x values, giving us y equals 1 squared minus 2 times 1 minus 3. 1 squared is 1, negative 2 times 1 is negative 2, and then we have the minus 3. 1 minus 2 minus 3 is negative 4. Putting these two values together, we get the ordered pair 1, negative 4, the location of our vertex. In part B, we need to algebraically find the horizontal intercepts. It is important to remember the horizontal intercepts are the points on the x-axis, and every point on the x-axis has a y value of 0. So we're needing to solve the equation 0 equals x squared minus 2x minus 3. To solve this equation, we will use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Putting that to use with our particular equation, we end up with x equals the opposite of negative 2 plus or minus the square root of the quantity negative 2 squared minus 4 times 1 times negative 3, all of that over 2 times 1. Simplifying that, the opposite of negative 2 is a positive 2, plus or minus the square root of negative 2 quantity squared is 4, negative 4 times 1 times negative 3 is plus 12, and in the denominator, 2 times 1 is 2. So that gives us 2 plus or minus the square root of 4 plus 12, all over 2. Continuing to simplify under that radical, 4 plus 12 is 16, and this gives us 2 plus or minus the square root of 16 over 2. Taking it one step further, the square root of 16 is 4, so we now have our two solutions, 2 plus or minus 4 all over 2. We do need to work out those solutions individually, so the first possibility is that x equals 2 plus 4 over 2, so x equals 6 over 2. The other possibility is that x is equal to 2 minus 4 over 2, or negative 2 over 2. In the first possibility, 6 divided by 2 is 3. In the second possibility, negative 2 divided by 2 is negative 1. This gives us our two x-intercepts, or horizontal intercepts, of 3, 0 and negative 1, 0. In part C, we now need to algebraically find the vertical intercept. The vertical intercept is also called the y-intercept, and we find the y-intercept by making x equal to 0. So taking our original equation and substituting 0 for the x's, we end up with y equals 0 squared minus 2 times 0 minus 3. 0 squared is 0, negative 2 times 0 is 0, so 0 minus 3 is negative 3. Giving us a vertical intercept or a y-intercept at 0, negative 3. In part D, does the parabola open up or down? Well, looking back to our original equation, we can see the leading term was x squared. When the leading term is x squared, this is implying that the a value is 1. And since the a value is positive, we know this parabola will open up. And in part E, what is the axis of symmetry? The axis of symmetry is the vertical line that goes through the vertex. It is the vertical line that in this case is x equal to 1. And the final part of this example is part F, to graph y equals x squared minus 2x minus 3 on the graph that is provided. First, we need to draw in the axes. Make sure we label them and put arrows on them. We also need to put a scale on the axes, looking at all the x and y coordinates that we have calculated, This will fit if we use a scale of 1, 2, 3 on each axis. And now we need to plot our points. Our vertex is at the point 1, -4. Our x-intercepts are at -1, 0 and 3, 0. And our y-intercept is at 0, -3. It is important to remember the symmetry and that the axis of symmetry does go through the vertex. So if there is any point to the left side of the axis of symmetry, there will be a point mirrored on the right side. In particular, we have the y-intercept right here at 0, -3. That point needs to have a mirror point, or a symmetrical point, on the other side. In this case, it would be at 2, -3. One of the advantages of having the symmetry is for every point that we calculate on either side, we obtain a free point, without any additional calculation, on the other side of the axis of symmetry. The final step is to connect these dots with a smooth, symmetrical parabola. This is a graph that will need to be done freehand, and you do not want to use a ruler to connect any of these points. Again, when these are drawn by hand, we are not looking for perfection, but we are looking for something that is as smooth as possible with as much symmetry as possible.